Assalamualaikum warahmatullahi wabarakatuh. To Dr. Muhammad Razali bin Mat Tamari. My name is Ummu Zahratu Kareha binti Zakaria. My matric number AE170059. And my other group member is Nurul Zainani binti Zaini. Her matric number AE170037. Today we will present for the assignment 2 project. For the introduction, in this project, we were given with the different type of recyclable materials. Recyclable materials are including glass container, newspaper, aluminum can, and plastic bottle. In order to analyzing the different types of recyclable materials, a convolutional neural network (CNN) can be applied for image classification. CNN is a fixed version of a multilayer perceptron. Multilayer perceptron usually means a fully connected network. In example, each neuron in one layer is connected to all neurons in the next layer. The full connection of these networks make them vulnerable to overfitting data. Moreover, CNN use relatively little preprocessing compared to other image classification algorithms. And lastly, VGG16 is one of the famous models submitted to ImageNet large-scale visual recognition. Next, this is a simple figure of the CGG16 architecture. It consists of multilayer perceptron, including convolution plus ReLU, max pooling, fully netted plus ReLU, and softmax. For the methodology in this project, we start the project with design the CNN model. Next, we rewrite the coding, and then we test the simulation. If the simulation test is run as expected, the result and analysis is produced. If no, we should write the coding again and do the simulation test. This is the block diagram for the CNN. First, the input layer with input neuron 28 times 28. Then convolution 1, 32 filter and max pooling. Then convolution 2, 64 filter and max pooling. Then convolution 3, 64 filter and max pooling. Then flatten. Then hidden layer with hidden neuron 64. Then produce output layer with output neuron 10. Convolution 1, convolution 2, convolution 3 is local feature extraction.
Hi, Assalamualaikum. My name is Nurul Zainani binti Zaini, matric number AE170037. Now I will do the simulation of our assignment 2. We do the simulation on Google Lab using the Python language. So for the task 1, we need to train the image from folder. So for the step 1, we connect to Google Drive. We connect to content drive until we get this notification mounted at content drive. And then step 2, fit dataset directory. So our dataset directory, which is recycle 2, which is our datasets given. And then for the step 3, we create train and validation data directory. So for the path, for the train directory, we use the train folder under the recycle tool. And can and pet train directory is for the train is below or from the train folder have been given. So for the validation directory is same. We get from the recycle folder and get and pet validation we get from the val folder given. So for our test directory, we use the image that we have been asked to find the image. The characteristic of image is like this. The image must be put both items side by side, and then for the second image we have to move the pet bottle backward around 10 to 15 centimeter, and then while turning the camera position, and then take the second picture. So for the third picture condition will be the same as the second picture, but the can will be at the back and the pad will be at the front. Okay, so next we print can string length, and then we pad string length, we can and pad validation length, and then also same as the test length, and we get the result is here. Can string length 156, pad string length 310, can validation length 79, and pad validation length 133, test length 3. So we import the TensorFlow as the train, as the identifiers, and then step 4 we construct the convolutional neural network model. So we our model is use 32 filters for the convolutional layer first, and then activation value. So our input shape we key in the 150 times 150. So the and then we max pooling to 2, and then for the convolutional layer 2 we set is as 64 33, and then max pooling to 2. Convolutional layer 3 we set is 128 33, and then max pooling to 2, and then we flatten it. Our dense will be 512. So we form the architecture of our model. This is our architecture of our model. So this before we process the input data, we first do the pre-process the input data. So our train data generator must multiply by risk equal to must be calculate as risk equal to 1 divided by 255 before applying the transformation, because we want to get the normalized value 1 to 0. So and then as a train generator we use the target size of 150 times 150. The best size is 30 and class mode binary. So for the validation generator we use the target size 150 times 150, batch size equal to 20, class mode binary. So we get this outcome or input, found that 466 image is belonging to 2 classes, found that 212 image belonging to 2 classes, database shape 30, 150, 150 to label batch shape 30. So for the step sheet, we start the training process by keying the epoch 30. And the step for epoch, we use the length of train generator, and for the same as the validation data, we use validation generator, and validation steps we use length validation generator. So this is our result that we get. Most of the result is near to 1, which is its accuracy is near to, most of the accuracy is 100%. So we plot the outcome to see the graph, and then this is this is our result after we plot the graph. We get most of the epoch have 100% training accuracy, and validation accuracy is quite high at this moment. So we maybe have already overfit the train, and then we have the training loss and validation loss like this. Most of the validation loss, most of the epoch that have a validation, that have a loss of less than 0.5. So next we do the testing instruction. We have to fit sample image to observe which is dominant, pet or can. Pet, then we first put pet and can at side by side, and then this is our coding. So we get the result is this image is 100% can and 100% cat after we put it side by side. So when the pet far behind, this the result will be shown as here. The image is 100% can and 0% pet. But when the cat far behind, the image will result like this. This image is 0% can and 100% pet. So for the fit all the images, all the three images, we first save the model as test, and then we do the data, we do the test generator, and we define it as image data generator, and we must rescale it 1 divided by 255 before applying the transformation. And then we use the target size of 150 times 150, and we use the batch size of 20 and class mode binary. And then we found that 0 image is belonging to the two classes. So this is our model architecture: conventional 1, conventional layer 2, conventional layer until 2 only. And then this is our branch. Okay, that is for test 1. Next is for the test 2. The test 2, test 2 is we must select any of two pretrained model. Then we select the VGG and interception. So first we need to connect to Google Drive, same as test 1, and step 2 we feed the dataset directory, and then we create train and validation data directory, same as test 1, and then but we yes, same as test 1, and then we import TensorFlow. And then for the step 4, construct the CNN model, we use the conventional base TF application VGG16. So the weight is we use the image net. We don't want to include the top, so we just make it false. And the input shape is 150 times 150. And then for the conventional base trainable is still we don't want to use it, and then we just save it as false. And this is our model architecture, model VGG model architecture from the data sets, and we use the VGG16 pretrained model. So for the as you can see here, for the conventional layer 1 we get this output shape, and then conventional 2, and then we max pooling, and then conventional 2, and then this is the result that we get. So okay, this is the result that we get. Okay, and then we state is to form the architecture, we must state the dance or activates it in here first, and then we form the architecture of the every conventional network that we have to train. So this the result that we get for the sequential tree, we get the VGG16 functional is like this, output shape 44510, and then we pattern, you get this, and then stands. So there is have the trainable parameters and non-trainable parameters because of the FRITS conventional AU network. So for the pre-process the input data, we use the same. We must train the data generator and do the rescale of 1 divided by 255 to before applying the other transformation. We must normalize the value from 0 to 1 value, and then there has 3 methods that flow from directory and flow from data frame. So for the train generator here, we we make the target size as 150 times 150, and then the batch size we use 30. Since we use the binary concentration loss, we need binary labels, so we use this binary smart for binary. So for the validation generator, we use target size of 150 times 150 and batch size of 20 class 1 of binary, so that we have this in output. And then for the training process, we use the epoch of 30. We use 30 epoch, and step per epoch is we use length of string generator, and validation step is length validation generator, and then we get this value here, and then we plot the outcome. We plot the graph to see the is for us to see the result of the train model. And then this is the graph that we get after we train the dataset with VGG16, and then we get most of the epoch, not most, but currently it almost all the epoch is almost of the epoch have 100% accuracy. And then for the loss, the epoch, most of the epoch have has less than 0.25 loss. Okay, that is the train with VGG. And then we train it. We train the data sets by using the inception. Sorry. Inception. So for the step 1, as same like before, connect to Google Drive, and we must feed the dataset directory. And then for the third step, we create train and validation data directory. The data directory that we use is Steam for this Steam S+1, and then it's the same as the training with G, and we get the output here, and then we import as from Keras, import layers, from Keras import models, from Keras import optimizer, from Keras compression image, and from Keras import losses, from Keras matrices, pre-processing image, and then we define the image data generator. And then for the pre-process input data, we use the train data gen. We must do the rescale value of 1 divided by 255 before applying the transformation. So we use the rotation range of 40 with shift rate of 0.2, height shift range of 0.2, shear shift range 0.2, horizontal flip as true, because we want to get the horizontal flip value. Okay, so for the train generator, we use the target size 150 times 150, and batch size equal to 30, and class mode is binary. And then the validation generator, we use the target size of 150 times 150, batch size of 20, class mode of binary. So we first define or identify the inception. That is this, we use the base model equal to inception. Our input shape is 150 and 150 3, and then we do not want to include the top, and the weight is we use the as image snake. So we found that 460 image is belonging to 2 classes, and then we found the image from the dataset is 212 image from the dataset is belonging to 2 classes. So for the step 5, reprocess the input data. The coding is like this. We use the input transfer flow, and then x equal to layers, we flatten, and then x equal to layers dense, we use the value of 10 is 512, and the iteration value, and then we drop out it by 0.2, and then x equal to layer dense 1 iteration sigmoid. So we compile the model by model compile optimizer RMS prop like this. We use the binary concentrated matrix is accurate. So for the step 6, we start the training process. Same, we use epoch of 30, and step per epoch is length train generator. Validation step is length val generator. So this is our result. Most of the loss value is near to 0, and most of the validation or accuracy is near to 1 or 100%. So we plot the outcome. We have trained the data sets, and then we get this graph like here, and we get the most of the epoch is above the 95% accuracy, and then the loss is we have less than 2.02, less than 0.25 for the loss for the validation loss. So compared to task 1, after we train the datasets with VGG and inception, we get the optimum or the good value of, or we have the high accuracy value and less losses value after we train with the VGG and inception. I show you the comparison of our result. Okay. Okay, this is for the task 1, we get the value is like this, and for the task 2, with VGG, we get the graph after training the dataset like this, much more optimum and much more high accuracy and less validation loss than compared to task 1. Same as inception, we have the higher percentage accuracy and less validation loss or training loss after we train with the pre-trained model. Okay, that's all from me. Thank you.
Next, this is the result and analysis for task 3. First, a method that can be able to solve that problem is AE170039 CNN. Second, many kernels of the same size are used in a single convolutional layer. Third, the last fully connected layer is fed into the 1000 wave softmax function corresponding to 1000 class levels. Fourth, max pooling layers are placed after the cross-channel normalization layers and the 16th layer. The ReLU nonlinearity is used after each convolutional layer. The neurons in the fully connected layers are connected to all neurons in the previous layer with 4096 neurons each. For the conclusion, we are successfully designing a CNN model and fine-tuned until getting the high validation performance. Second, we successfully analyzed the outcome of the multi-layer perceptron model. Third, we are successfully analyzed the suitable algorithm that can be used. And lastly, finally, the CNN can be applied in a recyclable industry. That's all from us. Thank you.